Hi everyone, this is Adam here. So today I'm going to go over statistics and the normal distribution. I'll probably go up to, to be honest, I'm not sure how much I'm going to cover. I'll definitely go over this normal distribution and how you calculate it anyways, and then kind of go from there. Okay, so what is a normal distribution? So this will look, this is what's in your log tables. Here we have z-scores, okay? So these are all z-scores down here. So it's just a score you get, which kind of just tells you where you lie within a population, okay? So all of this stuff, don't even bother. You can just forget about it, okay? So we don't need any of that. We just need the picture, okay? So a z-score is something you get. So first of all, let's say we have a population and it's normally distributed. What does that mean? That just basically, it means it looks like this graph that we have here. Okay, so it just means that if I say, so height would be normally distributed in Ireland. So if we look at the average height of a man, it's like 5'9" or 5'10" or whatever it is. So that would be this 0 here. Okay, sorry, white is like literally the worst thing I could do. So that would be if your height was exactly average. But let's say you were maybe 6'2" or 6'3", you could be somewhere over here. And then if you were 5 foot, you might be somewhere down here. So it basically just says, where are you compared to everybody else? Are you really tall? Are you really small? Where are you compared to the average and compared to everybody else? So it'd be one of those things of, if I told you that, so like here, this off over here, this would be if someone was like maybe 6'7". And you might be wondering, okay, well, it's very small. Why is it very small? The reason it's very small is because there's very few people who are 6'7". There are tons more people who are the average height than there are people who are, say, 6 foot, and people who are maybe 6'3" and then 6'7". So the graph goes down, the less likely it is. One thing to remember is that the area under this graph is 1. So it's 100%. Okay, that's all you need to know. That the whole thing is 100% because obviously it has all the heights. So of course you'll have 100% of the population. That's kind of all it is. Okay, a z-score basically tells you where you are in that population. So a z-score of 1 over here basically tells you that you're in the upper half and you are taller than this many people. If we go down to a z-score of 1, what do we get? So 1.00 is this, which means there is roughly 84% of people are shorter than you, and then 16% of people are taller than you. That's what a z-score does. It just tells you where are you compared to everybody else. Okay, that's all. That's all a z-score is. That's all the normal distribution says. It just says that this is kind of what you're doing. Okay? And typically for populations, your normal distribution will be a normal distribution. So it doesn't have to be a normal distribution. If you look in your log tables, there will be other distributions, but typically they will look normal like this. Okay, so let's do a couple of things. So it's just going to be calculating out what these different things are. So let's just say we have this thing and it says Z has a normal distribution of 0 and 1. So basically they'll tell you it's normally distributed 0 and 1. So basically this means that this is your mean or average. This then is your standard deviation. Standard deviation, okay? Now, I'll explain in a second what that is, okay? But just for now, what this means is, so it's normally distributed with 0 and 1, which basically means it's just this thing up here. So if you're wondering why is it 1, 2, and 3, it's just that's it. That's all you have to worry about, okay? So again, it looks something like this, where this is the average, it's down the middle, it's 0. This is also symmetric, in case you're wondering, the left-hand side is the same as the right-hand side. They're telling you that if you get a z-score between minus k and k, you basically have that it's going to be 0.1428. So this is the probability of getting something in here. So the chance that you get something in here is equal to 0.1428. Okay? Now, basically, how do you calculate this out? So remember, this is just area underneath the graph. So if you calculated this purple area or pink area here, you would get 0.1428. That's fine. Now, remember, the standard deviation is 1, which basically means that this length here is going to be the same as the area underneath. So it's 0.1428. So therefore, 2k is the length of that. So from minus k to k is just 2k. So that's equal to 0.1428. So k is equal to 0.0714. So that's how far left and right you go. Okay? So that's all. So that's kind of what you're doing in this. Okay? Now, that was just one example of like how you would do that. If they asked you what's k minus k to k, how would you do it? Now what I want to do is I want to do a bit more of how do you actually calculate these out. Okay, so just calculating out z-scores. So a z-score, z. So z, which is z, is equal to x minus mu over sigma. Okay, now what is x? So x is kind of what you are or what you're testing. So if I said, again, back to the height analogy, if I was like, okay, so this guy is 6'1", okay, where is he? Then x would be 6'1". So it's x is kind of like, what are you testing for? So what are you like measuring where it is, okay? Mu is the average or the mean. And then sigma is your standard deviation. Okay? Now, what is sigma? So sigma, the standard deviation. So what actually is it? So the standard deviation is basically, it's a measure of how spread out your data is. Okay? So it's basically just like, okay, so if you go, so, okay, the best way to describe it is using the empirical rule, which you definitely might know. I might need to know. I'll just see if it's here, just so I don't make a mistake. The empirical rule. Okay. I think the empirical rule basically tells you that if you look at data and go from minus sigma to plus sigma, minus 2 sigma to 2 sigma, and then minus 3 sigma to 3 sigma. Basically, if you go from minus sigma to sigma, you would capture 67% of the population. So 67% of the population is within 2 standard deviations. Okay? This is going to be 95. And then this is 99.7. Okay? So that's, again, I'll check this before the next video, but just in case this is incorrect, this could be 68. I'm not sure, but around 67 or 68%. Okay? So, you know what, just because it'll annoy me if I don't. I'm just trying to look it up now. Okay, I'm very sorry. I should have looked at this beforehand, but so the empirical rule formula basically gives you, okay, just as well, I looked at it. It's not 67, it is 68. Okay, sorry about that. So it is 68%, not what I said was 67. So basically, this is kind of what the standard deviation tells you. It tells you that if the standard deviation is very big, you'd have that 68% of the population is quite spread out. So it just kind of tells you how far left and right of the mean you have to go to capture 68%, 95, 99.7. So this is actually quite an interesting one. The 3 sigma up and down. So it's one of those ones of like, I don't know what the standard deviation for heights are, but I would imagine that it's probably around maybe 4 inches, I would say. Because if you say that the average height is, say, 5'10", okay, for a man, then basically what that's saying is that if you went across all Ireland and you measured everybody's height, if you do 5'8", or sorry, 5'10", and you say sigma is equal to 4 inches, then basically that means if I take 3 sigma off it, I'm left with 410. And if I add 3 sigma, I'm left with 610. So would you imagine that if I went around, I'd only for every 1,000 people, I'd only find 3 that wouldn't be in this range? You'd probably say, okay, yeah, that's kind of believable, you know? So that would be something like what the standard deviation for the heights would be. So even though I don't know it, I can make a good guess as to what it is. So the standard deviation just tells you like how spread out is your data. Okay. So so height would be quite, I suppose, narrowly spread compared to like, you know, if your average height is, you know, 5'10", the standard deviation is quite small. Like 4 inches is quite small compared to 5'10", you know. So other things might have quite a large standard deviation. Like maybe on like the buses, if you look at the different routes, the amount of people that would be on those buses, that might have a larger standard deviation, because you might say, okay, the average of people on every bus is 40. You'd say, well, okay, but like you'd expect that on some routes would be very quiet. There might only be 2 or 3 of them there for some of the buses, especially early in the morning. And then for other buses, they'd just be jam-packed. So that you might expect that the data would be a bit more spread out. So that's what sigma does. It basically tells you how spread out that data is. Okay, if it's small, then everything's very bunched together. If it's large, then all the data is kind of spread out an awful lot. So yeah, that's kind of what this sigma is up here. Okay, so one of the things that I want to do is, it says the mean total score in Irish Basketball Super League games is 137. So the mean, you're told, is 137. Grand. It says you have a standard deviation of 10. So sigma is equal to 10. If you go to a match, what is the probability that there will be 150 or more points scored by the 2 teams? Then you would say, okay, well, I need that the probability is greater than or equal to 150. Okay, so I need more or less than 150. So what does that mean? If I go to my standard deviation table, my distribution, here, the mean is 130, so that's 130. And you have that your standard deviation then is 10. So this is just 10. Okay? So again, this is 140, and then this would be 150. So I want to know how many of the games are here on the graph. Okay, so all I do is because a z-score, what it does is, so back up here, these numbers that we have here, and sorry, I'll do a different color again. So all these numbers, they basically signify how much of the gray area, so how much is left of the number. So obviously, if I go down here and say, well, if I go left of this number, I'm getting all of this area. So all I need to do is just 100% or 1 minus whatever the area is, and I'll be left with the pink area. So let's get the z-score. So z-score is going to be 150, which is what I'm testing, minus 130, divided by the standard deviation, which is 10. So I get z equals 2. Grand. So you go back up to your table here, and you find where 2 is. So you go to the left first, and you say, okay, 0, 0.1, all the way to 1. Then you go to the next table. You keep going down until it's 2. It's 2.0, which means I want this one. So it's going to be 0.9772. So this means this corresponds to 0.9, is it 9972 or? I feel like it should just be 7. I don't think it should be 9. 9 feels too much. 77, yeah. So it's this. So basically this tells you that the whole thing up here is equal to 1. The blue stuff is equal to 0.9772. So the pink then is equal to 1 minus 0.9772. So it's equal to 0.0228. And that as a percentage is multiplied by 100, bring the decimal point over 2 times, you get 2.28%. So there's a 2.28% probability that your score will be greater than or equal to 150. Okay? All right. So that's that. Okay? Now I'm going to do another one, which is just what they're going to say is, okay, well, what about if they say, what's the probability that we're going to get less than 100 points in a game? Well, now we do the exact same thing, but now, remember, this is 130. We're now looking for 100, which is 30 over this way. Okay, so now what I want to know is, I want to know what is this area in here. So again, let's do the exact same thing. So z equals 100 minus 130 over 10, that's minus 3. Okay, so hopefully that's all okay. So now let's get that z-score. So let's go back up to the top and let's find minus 3. So look at the yellow and see, can you find minus 3 anywhere there? No. No, you can't. You can't find minus 3 anywhere. Why do you think that is? Again, pause the video if you want. The graph is symmetric, which means you only have to be given the right side to know what the left-hand side is. Okay? So a z-score, so instead of minus 3, I can get plus 3. So plus 3 is going to be 0.9987. So 0.9987. So that basically tells you that if we had a z-score of 3, this area would be equal to 0.9987, and then this area here would be 1 minus 0.9987, which is 0.0013. Okay, so this area would be equal to this. Now I can just do the exact same thing and say, well, minus 3, it's just flipped. So this area and this area are the same. And therefore, z is minus 3 would also give me a 0.0013 chance of happening, which is 0.13%. Okay? So you can also just do the minus of it. Okay? So just to be careful of that. I think I'll do one more question doing these. And basically the question is, it says, the heights of women in Ireland are normally distributed with a mean of 163. So mu is 163. The standard deviation is 5. Okay, so even smaller. So standard deviation of 5 centimeters, that's 2 inches. So that's even smaller than what I would have thought. But anyways, it says, a film producer is seeking an Irish actress whose height is between 170 and 175. The director says to the producer, "You are being too fussy. The chance of finding an actress with the right height is less than 5%. Is this statement correct?" So you want to know, what is the chance that you can find someone between 170 and 175? So again, you don't have to draw any of these out. If you know how to do these, perfect. I'm just drawing them out because I think it's a bit more obvious. So this is 163. And what we're looking for is, here is maybe 170. This is 175. We're looking for this area in here. So now what I can do is, I can calculate the area left of that pink line. And then I can calculate the area left of the second pink line, and then minus them off each other, and I'll be left with this little bit in here. Okay? So what I can do is, I can get my z-scores. So my z-score for 170, so z of 170 is equal to 170 minus 163 divided by 5. So remember, you're divided by the standard deviation. So it's going to be 7 over 5, which is 1.4. The z for the second one is going to be 175 minus 163 over 5. That's going to be 2.4. So those are the two z-scores that I need. So 1.4 and 2.4. So 1.4 is here, and then 2.4 is here. So it's going to be 0.9192. And then for 2.4, it's going to be 0.9918. Okay? If I minus these from each other, I'm going to be left with 0.0726, I think. So that's going to be 7.26%. So there's a 7.26% chance that you'll find a woman with a height from these two ranges. And just to address the question, so the question said it's that there's a less than 5% chance. The answer is, that's wrong. It's 7.26% chance. Okay, so yeah, that's kind of that. All right, I might just do. Let's be fair, I don't think that's actually come up, so I'm not sure if I'll bother. Okay, I think I might leave that at that, and then I'll go over more stuff about sampling, margins of error, z-scores, things like that, and then kind of go from there. So, I could just do it quite fast anyways. Yeah, I might just do it fast instead. So I'll just go over what the mean, median, mode, range, quartile, interquartile range, and then that'll be it. And percentiles. Just to make sure I cover everything in these videos, because I'd hate to have to do them again. Okay, so the mean is just the average. An example would be if I wanted to calculate the average ages of 18, 20, 27, and say that's one less, so I need one more, so 22. You would add them all up. So you do 18 plus 20 plus 27 plus 22, and you divide it by the total amount. So you divide it by 4. So that then is going to be 40, so 87, which is 21.75 years old. Okay, so that would be your average. The mode is just the most often. So if I said here, if it was 3, 3, 3, 7, 7, 8, 9, 10, 12, 12. And I asked you to find the mode. The mode is just equal to 3. Okay? So the median number then is just the middle. So the middle number, so first of all, let's say you have n things. So there's n bits of assets. Let's say there's 10 of them or whatever, or 12, there's n of them. You do n divided by 2. If n is, say, odd, so for example, if it was 7 over 2, you get 3.5, you round up. So the median is just the fourth number. If n is even, say it's 8, and you get 4, then you take the fourth and the fifth, and you divide it by 2. So let's say we have the numbers 1, 2, 3, 4, 5, 6, 7. There's 7 numbers, so do 7 divided by 2, get 3.5, round it up to the fourth one. So this is the median, because it's the middle number. You have three numbers left of it, you have 3 numbers right of it. If I, however, have 8 numbers, now all of a sudden it's n divided by 2, it's the fourth and fifth one. So it's this plus this, so you end up getting that the median is 4.5. Okay, so that's just one thing to be careful of there. The range is just the biggest minus the smallest. So the range for this set is just 8 minus 1, so 7. So that's it. All right. The next thing is going to be the quartiles. So the quartiles are the exact same as the mean. That's our median. Exact same, just as you probably guessed, it's quarter. So let's say we have, let's just say I have 10 things. I'm just going to say 1, 2, 3, 4, 5, 6. Okay, I might just do 6 instead. Actually, no, I'll just do 10. Okay, so if I asked you what the first quartile was, you'd say, well, there's 10 items. You divide it by 4. You get 2.5. You round it up. So it's the third item. So the first quartile, which is Q1, is equal to 3. The third quartile is going to be 10 divided by 4 multiplied by 3. That's going to be 7.5. You round that up to the 8th. Okay? Then with this one, you say the 8th number is just going to be 8. So Q3 equals 8. And then the interquartile range, that's equal to Q3 minus Q1. That's just going to be 8. That is the worst 8 I've ever drawn. 8 minus 3, so 5. Okay, so that's all the interquartile ranges. It's just, you're just taking a quarter, and that's it. Okay, so not too bad. Okay, so that's the interquartile range, and the very last thing then is percentiles. That's the very last thing that you could get into. So a percentile is just how much of the data is below you. That's all percentile is. So if you're in the 75th percentile, that means that 75% of the data is below you. That's what it means. Okay? So if I just did a quick example. So it says, so first of all, let's say the data is this. So these are just scores in a test. 96, 96, 98, 98, 98. So that's it, okay? Now, it says find P30. So that's find the 30th percentile. So first of all, you say, well, there's 15 different things. So do 30% of it. 30% is just 3 over 10. So you end up with 4.5. 4.5 isn't the whole number, so you round up. So it's the fifth. So 1, 2, 3, 4, 5. So you end up that the fifth value is 92. And therefore P30 equals 92%. So if you're 92, then that means that you're in the 30th percentile. Okay. P80 then is the exact same. You do 15 times 80%. Okay, and so we end up with 12. Now, whenever you get a whole number, you do the same thing as the median. You take the 12th and the 13th and you divide it by 2. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 96 plus 98 over 2 is 97. So the 80th percentile is 97. Because if you look at 97, 97 would be here, which means that exactly 80% of the data would be below it. And so that's what a percentile is. Okay? All right. So that's more so like a recap from Junior Cert, to be honest. They don't really come up. I don't know to have them in a video just to have them just in case, explaining what to do. And that's kind of just like a crash course on those different things. And that's kind of that. Okay. All right. I think I'll leave it there for today. I'm going to finish statistics in the next video I do. So that'll be all about the different standard deviations, stuff like that. And then that'll be it for probability and statistics. So probability and statistics kind of go hand in hand. Okay. And then once that's done, I'll be going on to trigonometry and geometry and then going from there. Okay. So I suppose thank you very, very much for paying attention. And I think I'll see you in the next video. Bye.